This video has more operations with radical expressions. Be prepared to do a lot of pausing through this. I'm going to try to go through rather quickly. There's a lot of different operations that are going to happen here. So, radicals that cannot be simplified are not rational. Okay, like the square root of 2 can't be written as a fraction. So you're saying rational, but it can't be expressed by a fraction. Square root of 3 is not rational. I can't write it in the form of a fraction. The cube root of 9 is not rational. The fifth root of 7 is not rational. The fifth root of 75 is not rational. The square root of 6 is not rational. Some of these might be able to be simplified somewhat, but they'll still have a radical left over, and therefore they're not rational numbers. Denominators always need to be rational numbers. If they're not, it's bad. It's considered bad form. So when we say to rationalize a denominator, it means that we need to clear any radicals that are in that denominator because they wouldn't be rational numbers. So in this case, I've got 3 divided by the square root of 2. I have a square root in the denominator, and that's not rational, so I need to find a way to clear that square root. Well, if I multiply this by a fancy number 1, if I multiply it by the square root of 2 over the square root of 2, I see that I get 3 root 2 over 2. And now my denominator is a rational number. It's the number 2. So that's good. Here's another problem. I have 5 being divided by the cube root of 2. Well, that needs to be a 2 cubed. I can't, it's not a rational number because the cube root of 2 is not rational. I need to have the cube root of 2 cubed, not, just 2 squared, but 2 cubed. So what can I do? How can I make that 2 cubed? Well, again, remember you have to only multiply by the same index. So I'm going to multiply by the cube root of 2 squared, because the cube root of 2 times the cube root of 2 squared is going to give me the cube root of 2 cubed. But you can't just multiply the denominator only. We have to multiply the numerator as well. So we end up with 5 cube root of 2 squared, which is 5 cube root of 4. And since we now have the cube root of 2 cubed, that's just 2. And so we have rationalized the denominator. Now, more multiplication going on here. This is going to be about distribution. So, if I have the square root of 2 times this group of the square root of 3 plus 5 root 14, well, I just distribute that square root of 2, and so it's going to equal the square root of 2 times the square root of 3, which is the square root of 6. And I'm going to do distribution here of square root of 2 times that. Well, I'm going to get 5 times. Oh, now I have to do that simplification. So I'm factoring. I'm saying square root of 2 times the square root of 2 times 7. Well, that's going to make a 2 come out. So I'm going to end up with the square root of 6 plus 5 times 2 times root 7, which is the square root of 6 plus 10 root 7. And that's the final answer because, as we talked about in our addition, we can't collect those terms because one's a square root of 6 and one's a square root of 7. But that is the multiplication of that monomial, the square root of 2, times the 2 terms, the binomial. And here's another situation where this time I have cube roots. 4 cube root of 6 times 2 cube root of 18 minus 5 cube root of 12. I think there's going to be a bunch of simplification that's going to have to go on here. So first of all, 4 times the cube root of 6 times 2 cube root of 18. Well, I've got the 4 times the 2, which is 8. And then I'm looking at this cube root of 6 and the cube root of 18. And the cube root of, well, 6 can be written as 2 times 3, and 18 is 2 times 3 times 3. Well, I've got 3 times 3 times 3, that's 3 cubed, which means a 3 can come out. But the 2 times the 2 is going to have to stay behind. So you see what I've got there? 2 squared times 3 cubed. Now I'm going to distribute the 4 cube root of 6 times 5, well, it's negative 5 actually, because of subtraction there, negative 5 cube root of 12. Once again, I'm going to multiply the 4 and the 5, the integers on the outside, and I get 20. And then I'm going to look at the radicands. I've got 6, which is 2 times 3, and 12, which is 2 times 2 times 3. And so when I write that in the radical symbol, I've got the cube root of 2 cubed times 3 squared. So in that first problem, the 3 is going to come out. I'm going to have 8 times that 3, which is 3. Well, of course. And then what's left behind is still the cube root of 2 squared. Minus 20, and then what's going to come out of that radical is the 2. So 20 times 2. And what's left behind is the cube root of 3 squared. Simplifying, I get 24 cube root of 4 minus 40 cube root of 9. I can't collect these any further, so that's my final answer. In the third problem, we have what's like two binomials, and we're going to be doing some FOILing for this one to multiply this. So we're going to multiply the first, 3 times the square root of 2, and we get 3 root 2. Now we're going to multiply the first times the last, so 3 times negative 6 square root of 5. Well, that's going to be negative 18 square root of 5. Now I'm going to multiply the inner there. I've got positive root 5 times positive root 2, which is going to give me positive root 10. And now I have root 5 times negative 6 root 5. Well, that's, let's think about that. Negative 6 root 5 times root 5. Well, those two, that's going to give me a 5. So I'm going to get negative 6 times 5, which is negative 30. There's nothing to collect, so that's the final answer. In problem number 4. Oh, look at those. I've got 3 plus the square root of 2 times 3 minus the square root of 2. There's something very important about those two groups. It's a conjugate pair. Because I'm adding, it's 3 and root 2. And in one case I'm adding those, in the other case I'm subtracting them. And recall that when we are ever multiplying the conjugate pair, a plus b times a minus b, we always get a squared minus b squared. So the big question is, in the problem we're doing, what's my a? My a is 3. That's the first part of that. And what is my b? My b is square root of 2. So if I just went straight to the end and say, well, I'm going to get a squared minus b squared, well, just write that, the 3, and use parentheses. It's very important. 3 squared minus the b, square root of 2, squared. And what I get there is, well, the 3 squared is 9, and the square root of 2 squared is 2. Well, 9 minus 2 is 7, and that's my final answer. Notice something very, very, very important here. 7 is a rational number. We started off with radicals. It was the conjugate pair with square roots. This is for square roots only, not cube roots or fourth roots, for square roots. I have the conjugate pair of square roots, and I got a rational number, and that will always be the case, and that's a very important fact. So let's look at another pair of conjugate pair that we're going to multiply. And we notice that in this case, our a is the square root of 7, and our b is the square root of 2. So just going right to a squared minus b squared, I get square root of 7 squared minus square root of 2 squared, which is just 7 minus 2, which is 5. Another rational number. In number 6, I've got another pair of conjugates, where a is 2 root 3, and b is 3 root 2. So I write that it's a squared minus b squared, and now I have to square them. But remember that that square distributes. So that's not just the radical 3 that's being squared. It's 2 squared, which is 4, and square root of 3 squared, which would be 3. So I get 4 times 3, minus the b squared. I'm going to have 3 squared times root 2 squared. So I'm going to have 9 times 2. Well, 4 times 3 is 12, and 9 times 2 is 18, so I have 12 minus 18, which is negative 6. Now, that's a rational number. It's a negative number, but it's still rational, and that's important. So here's another one. Oh, well, wait a minute. What's this? This isn't a conjugate pair. This is a fraction. But in the fraction, there's a square root. And we're not allowed to have square roots in our fractions and the denominators. We have to have only rational numbers. So I need to figure out a way to turn that denominator into a rational number. And we've got to rationalize that denominator. So how can I turn that into a rational number? Oh, if I multiply by the conjugate, I will get a rational number. So I'm going to multiply the square root of 11 plus 2 times the square root of 11 minus 2. But if I multiply the denominator by that, I have to multiply the numerator as well. So, first of all, I'm going to distribute the numerator. 5 times the square root of 11 gives me 5 square root of 11. 5 times negative 2 gives me negative 10. In the denominator, since I'm multiplying conjugates, and my a is the square root of 11, and my b is 2, I'm going to get the square root of 11 squared minus 2 squared. Well, that's going to be 11 minus 4, which is 7. So my denominator is going to be 7. So I have 5 square root of 11 minus 10 all over 7. Now, that would be an okay answer, but it's really not the best form. As we go further in this topic, we're going to find that a better form would be to write each one of those parts of the numerator over the denominator. So 5 root 11 over 7 minus 10 over 7, because they're both being divided by 7. And this is the better form to finish the answer with. Let's try that again. Here we have another fraction with square roots in the denominator. We're not concerned with the square roots in the numerator. We don't really care whether we have square roots or not up there. It's the denominator that we care about. And so we look at that, square root of 5 minus 4 root 3, and we multiply by its conjugate. Square root of 5 plus 4 square root of 3. We have to also multiply the numerator as well. A lot of distribution to go here. So I'm going to play this kind of quick. You're going to want to pause this several times to make sure you see what's going on. So I've got 2 root 7 times root 5, 2 root 35. Then I have 2 root 7 times 4 root 3, which is 8 root 21. Then I'm going to have root 3 times root 5, which is root 15. Then I'm going to have root 3 times 4 root 3, which is going to give me 12. That's going to be 4 times the 3. Okay. Now we're looking at the denominator. Well, we're going to have the a squared minus b squared, so root 5 squared minus 4 root 3 squared. And remember, the 4 root 3 is going to be 16 times 3. So I'm going to have 5 minus 48 for that denominator, which is negative 43. So I write the entire numerator all over negative 43. And again, you could stop here, but it's really not the best form. And I want you to get more in the habit of writing it, each one of those parts of the numerator over that denominator. And so this is the better final answer. And that's where I'd like to see your problems go to. Again, you might want to pause and replay that. So that's the end of looking at the simplification.